Next. No. So the index, we started index, we discussed about index. Okay, then. So what is index? How to create index? How it works? When you submit the query to Oracle, okay? So how it will fetch the salary equal to 3,000 through index, through table? What the difference through table, through index? What the difference? So that is what we discussed in last class. And the index we created, this index is called simple index. So it's created on what? Single call. Next, one more is there. What is that is? Composite index. Okay, then. Okay, now. And see, and after creating the index, for which queries it will use index, for which queries it will not use index. I created index on salary. So I submit this query. So it will use index or not. I submit the query in that where condition based on salary. Will it use index? Yes. Because index created on salary, where condition is also based on salary. It will use index. Then what it will do? 3,000. 3,000 is complete. Then go to left side. Equal. Value is equal, less than, go to left side. Value is greater than, go to right side. So 3,000 is equal to 3,000. Go to left side. Next 2,000. 3,000, 2,000 is compared. 3,000 is greater than 2,000. Go to right side. So 2,500. This is leaf node. There is a leaf node with 2,500. There is a leaf node with 2,500 means there is an employee salary 2,500. Condition false. Next one 3,000. 3,000. Condition true. Once condition true, take this what? Address, row IDs. Address, take this address, go to table, select the row. So this is the address. With the help of this address, it go to the table, select this row from the table. Yes or no? Then. So number of comparisons are what? Reduced. 1, 2, 3, 4. In 4 comparisons, are able to find out salary equal to 3,000. If it goes to table, how many comparisons? 8. 1, 2, 3, 4, 5, 6, 7, 8. 8 comparisons. Okay. Then, so table 8 comparisons, index 4 comparisons. Number of comparisons are reduced to off. So performance is what? Improves. Okay. Then next, so, and not only this query. Okay, na? Not only this query. So then, not only this query. Oh, one second, just a minute. Uh, hmm. Okay. And here you see this, not only this query, suppose my query is salary greater than or equal to 3,000. Salary greater than or equal to 3,000. Then what it does? 3,000. So it takes 3,000. 3,000, 3,000 is compared. Then go to left side. 3,000, 3,000 is compared. Then go to left side. Okay. So then consider only this value. Don't consider this condition. Okay, na? Only this value 3,000. 3,000, 3,000 is compared. Then 3000 is equal. Then go to left side. 3000, 2000 is compared. Then go to right side. 3000 is greater than what? 2000. Right side. Go to right side. Now it is come to the leaf node. Once it come to the leaf node, then check the condition. It check this condition at leaf level, not at the root and intermediate levels. It will not check the condition. So root and intermediate level, it check this value. But once it comes to the leaf node, then it will check this condition, whether condition true or false. Now it is come to the leaf node. So 2500. Is salary greater than or equal to 3000? No. 3000. 3000 greater than or equal to 3000? Yes. Condition true. 3000 is greater than or equal to 3000. No? Condition true. And this is selected. This is selected. And it also select the nodes which are right side to this 3000. It also select the nodes right side to this 3000. The nodes which are right side to this 3000 are what? Greater than 3000. Because if you see the tree structure, left to right, the values are in ascending order. Once it comes to this 3000, it also select the nodes right side to this 3000. The nodes which are right side to this 3000 are greater than 3000. Yes or no? But question is, how it will go to the right side? How it goes to the right side? From this node to this node, how it will jump from one node to another node? Because you see this. Here, there is a what, sir? You see this. There is a what? Interlink. There is a interlink. There are interlinks from one leaf node to another leaf node. There is a interlink. So with the help of this interlinks, it can move from next node, previous node like that. It can move from one node to another node. It can move to the next node. It can move to the previous node because these leaf nodes are interlinked. Okay, then. So once it comes to the 3000, take these addresses and it also select the nodes which are right side to this 3000. The nodes which are right side to this 3000 are greater than 3000. And how it will go to the right side? By using this what? Interlinks. Then it selects all these three, take these addresses, go to the table, select the rows from the table. This row, this row, this row, this row. Okay. So select this, all these addresses and go to the table, select the rows from the table. Now salary less than or equal to 3000. Then salary less than or equal to 3000. Then so 3000. First take this value. 3000 is compared. Then go to left side. Left side. 3000 is compared. 2000 is compared. So 3000 is greater than 2000. Go to right side. Right side. 2500. 2500 condition true na false? Salary less than or equals to 3000. 2500 condition true na false? True. Selected. 3000 selected. Less than or equals to? Yes or no? So 2500 is less than. 3000 is less than or equals to? Yes. And this is selected. And it also select the nodes which are left side to this 3000. The nodes which are left side to this 3000 are what? Less than 3000. So after coming to this, it also select the nodes which are left side to this 3000. The nodes which are left side to this 3000 are less than 3000. How to go to the previous node? By using this what? Interlinks. With the help of this interlinks, it go to the previous node, select all the nodes. Understood that? But for this query, it will not use index. It will use table scan. Why? Because here tree is based on what? Salary. But here where condition based on what? E-name. By using this where condition, okay. So is this index is useful? No. Is this index is useful to locate the Blake record? No. This index is useful to locate the records based on salary. No. So for this query also, it will not use index. It will use table scan. But how do you know for particular query, Oracle is going to the index or Oracle is going to the table? Okay, na? Then what you have to do, you have to see the execution plan. If you see the execution plan, then you'll understand Oracle is going to the table, Oracle is going to the index. How to see the execution plan? Set auto trace on explain. So when you run this command, it will show for particular query, Oracle is going to the table, Oracle is going to the index. What is this is set auto trace on what set? Explain. Select start from what? Okay. Select start from page size. One second. Select start from what? EMP. Select start from EMP. So this is the query. Select start from EMP. For this query, what Oracle is? Oracle is what? Okay, na? Then for this query, Oracle is using what, sir? For this query, Oracle is using what? Table access. Okay, na? So table access full table scan. Suppose my query is this. What? Select what, sir? Start from EMP where salary equals to 3000. So for this query, Oracle is using what? Index scan. Which index it is using? I1. So it is going to the index, finding the what? Row IDs and go to the table, access the records by index row IDs. Table access by index row IDs. Understood that? Okay. Now, so what the next one is composite index. If index created on multiple columns, then index is called composite index. If index created on multiple columns, then index is called composite index. If index created on multiple columns, then index is called composite index. Example, create index okay, then create index what? I2 on EMP, then department number, comma, job. So create index I2 on EMP, department number, comma, job. So what this index is? This index is what? Composite index. So it's created on two columns. If you create on two columns, then index is called composite index. Okay. So when Oracle, see, after executing this command, internally one structure is created. What structure is created? B tree structure like this. Yes or no? Like this. So after executing this command also one structure is created. Tree structure is created. For the tree structure, it will be something like this. Okay, then. So suppose here 20. This is 10. 10 clerk star. 10 manager star. This is 10. Next one. Right side of 10. What? 20 analyst star comma star. 20 clerk star comma star. So this is 20. Next 30. 30 left side. 30 clerk star. Suppose 30, okay, manager star like this. 30 salesman star comma star comma star comma star. 4 stars. Why 4 stars? Why 4 stars? Because there are 4 employees. There are 4 employees belongs to 30th department working as salesman. In 30th department, there are 4 salesmen. So that's why 4 stars. So number of stars means number of rows. Number of rows in the table. Okay, then. So 20th analyst, how many? 2. 20th clerks, how many? 2. Okay, then. So this is what index is created like this. That means here When it is a composite index, root and intermediate nodes based on what? Department number. Leaf nodes contains department number and job. Root and intermediate nodes based on what? Department number. Leaf nodes contains department number and job. Root and intermediate nodes based on the first column. Here, what the first column? Department number. So root and intermediate nodes are based on first column. Leaf nodes contains department number and job. So when Oracle will use this index, Oracle use this index, select star from EMP where department number equals to 20. Suppose I give this condition. See, listen, when I give this condition 20, 20, 20 is compared, then go to left side. 10, 20 is compared, then go to right side because 20 is greater than 10. Go to right side. 20th analyst selected, 20th clerk selected. So it will take this row IDs, go to the table, select the records from the table. So for this query, Oracle uses what? Index scan. Oracle uses index. My query is this: select star from EMP where department number equals to 20 and job equals to clerk. Job equals to clerk. Select star from EMP, department number equals to 20, job equals to clerk. For this query, what? 20, 20 is compared. Then 20, 20 is compared. Then go to left side. 20, okay, now 20, 20 is compared. Go to left side. 10, 20 is compared. Then go to right side. In right side, it will apply this condition. Leaf level, it will apply this condition. Is department number is 20? Yes. Job is clerk? No. Department number is 20? Yes. Job is clerk? Yes. Take this what? Address. Go to the table, select the records from the table. So for this query also, it will use what? Index scan. Okay. Then, so for this query, it will use index. For this query also, it will use index. Now, select star from what? EMP where job equals to clerk. Select star from EMP where job equal to clerk. Then what? So you're asking for job equals to clerk. Hmm? So will it use index? No, because so you're asking for clerks. Okay. So then, but see this. If you want clerk records addresses are there in leaf notes. If you want the record address is there in leaf node. But can you directly go to leaf node? No. You go to the leaf node from root node and intermediate nodes. But root and intermediate nodes are based on what? Department number. But here condition is based on what? Job. By using this condition, by using this clerk, can we reach to the leaf node? No. By using this clerk, can we reach to the leaf node? No. To reach to the leaf node, what is required? Department numbers required. So that's why for this query, it will not use index. It will use what? Table scan. Okay. That means, see, when Oracle use the index, Oracle uses what's that? The composite index. Oracle uses this index when Oracle uses above index when where condition based on what? Where condition based on what's that? Like you say, leading column of the index. Leading column means first column. What is that is? That is what? Department number. Oracle uses above index when where condition based on leading column of the index. So what is the leading column is first column. So Oracle uses above index when where condition based on leading column of the index, that is department number. Okay. Then so to use this index, compulsory where condition should be based on department number. Here where condition based on department number, then it will use index. Here also it is department number is there, it will use index. But here department number is not there, so it cannot use index. Because to get the records from table, so it has to go to the leaf node because addresses are there in leaf node, but it cannot directly go to the leaf node. So to reach to the leaf node, so then what is required? It reach to the leaf node through root node and intermediate nodes. Root and intermediate nodes are based on what? Department number. So to reach to the leaf node, compulsory it requires department number. Okay. Then see when we recommend composite index, huh? Okay, now then sorry here once again. See actually when we recommend index first, next composite. Composite as simpler, that is secondary. First, when we recommend index, suppose user is saying that there is a query where salary equal to 3000 is running a query. Select star from EMP where salary equal to 3000. User is running this query. User is saying that boss, this query is running slow. I'm getting the output very slow. Okay, na? Is running one program or running one application, running a report. So that report is based on this query. That report is running slow because of this query. Because this query is running slow, so report is also running slow. Then what you do? So you have to improve the performance. Then so you try creating what's the index. You create index on salary car and check performance is improved or not. Okay. Then so like that, when you recommend composite index, okay, na? Suppose here once again, user is saying that this is the query where department number equals to 20. Select star from EMP where department number equal to 20, job equals to clear. User is saying that these two queries are running slow. User is saying that these two queries what's are running slow. Okay. These two queries are running slow. Then so what is the best one is create index on what? Composite department number comma job. Okay. If you create index only on department number, then if I create index only on department number, what happens is this query performance is improved, but this query performance is not improved. You understood? If you create only department number, this query performance is improved, but this query performance is not improved. But if I create index on department number comma job, if I create index on department number and job, then so then it will improve the performance of both queries. This query can take the advantage of index. This query also take the advantage of what's index. Both queries can take the advantage of index. So to improve the performance of these two queries, what the best option is create what's composite index. So on which you create index, it all depends on where conditions. Okay, then that's next. So then next. Okay, next one. What the next one is unique index. Unique index. Okay, na? Then so now what unique index? Unique index. Okay, unique index. does not allow duplicate values into the column on which index is created. Unique index does not allow duplicate values into the column on which index is created. Unique index does not allow duplicate values into the column on which index is created. On whichever the column you create unique index into, the duplicates are not allowed. Okay. On whichever the column you create unique index into, that column duplicates are not allowed. Example, I'm creating one unique index. How to create unique? We have to use this keyword. See, earlier, just we said only create index. If you say create index means it allows duplicates. Here you see that duplicates. There is 20 analysts too. There are 20 analysts, 2 employees, 20 analysts. There are 2 employees, 20 clerk. There are 4 employees, 30 salesmen. Duplicates are allowed or not allowed? Allowed. Here also, see that create index. When you say create index means duplicates are allowed. 3000. How many? 2. There are 2 employees sending 3000. Duplicates are allowed. But if you create unique index, duplicates are not allowed. Suppose I3 on EMP in brackets E name. Just example, but actually unique index is not recommended on ename because ename may contain duplicates. Ename may contain duplicates. Just example, just for testing, I'm creating unique index on ename. Actually, we don't create unique index on ename because ename may contain duplicates. So just example, I'm creating unique index on ename. Sorry, create what's it? Unique what? Index. Create unique index. Then so index created. Okay, index created. After creating the index, what happens? So internally, what? After creating this index, internally one structure is created. What structure? Tree structure. Tree structure is created. So what is the tree structure? Maybe that is something like this. Okay, maybe the tree structure is something like this. Then now, so this is Q. Q left side. Martin star. Maybe Miller star. Q right side. Q right side. Smith, Scott star. Smith star. Like this. So now it is based on what? It is based on what? Year, previous. So you created index on salary. It is based on what? Less than, greater than, yes or no? Okay, numbers, no? Numbers means less than, greater than. But this is what? E-name is what? Character field. Then it is based on alphabetical order. Alphabetical order. So what is like K is the root node? Just assuming I'm taking the K as what? Root node. So what comes left side to K? All the character that comes before K, left side. All the character that comes after K, right side. Alphabetical order. So the names that comes before G, left side. The names that comes after G, right side. Okay. The name that comes before Q, left side. The names that comes after Q, right side. That's it. So index is created like this. The structure of the index will be something like this. Okay, now okay, now let's see now. So then, when suppose next, this is my query. What is my query? Select star from EMP where ename equals to Blake. I submit this query to Oracle. Then what? I submit this query to Oracle. So it checks any index is there on ename. First, it checks any index is there on ename. Yes, there is an index on ename. That is I3. Okay. Then there is an index on ename I3. Next, it go to index. It go to the index K. K is compared with Blake B. So go to left side. K is compared with B. G. G compared with B. B is left side. Because B comes before G now, after G now. Before G, left side. So left side, there is a leaf nodes. So it checks any leaf node with Blake. So Adams, no. Allen, no. Blake, yes. Then take this one address. Go to the table. Select the record from the table. Understood? So then first B is compared with K. Go to left side. B compared with G. Go to left side. Left side, there is a leaf node. Checks any leaf node is there with name Blake. Yes, there is a leaf node with Blake. Take this one address. Go to the table. Select the row from the table. Now let's see. Suppose and run this query. So this is unique index. Index unique scan I3. Which index it is using? So it is using, so for this query, it is using index. Which index it is using? I3. So it is using index I3. Yes or no? That. So table access by index row ID. So it is taking the row ID in index, going to the table, access the record from the table. Okay. So this is select. Oh, okay. But not only select, suppose, for example, I'm inserting the record. I'm inserting the record into table. So whenever you insert a record into table, it is inserted into index also. Huh? When you insert a new record into table, it is inserted into index. Every new record inserted into table is also inserted into index. But in index, what is inserted? In index, what is inserted? Name. In index, what is inserted? Name, but not complete row. Complete row is inserted into table and name is inserted into index. Okay. And every new topic added to the textbook, the topic should be there in the index. When a new topic is added to the textbook, the topic should be there in the index. Similarly, whenever a new record is inserted to table, that should be there in the index also. So I'm inserting a new record, EMPNO, ENAME, salary, values, number, name, Blake, salary, what's that? 4,000. I'm inserting a new record into table. I'm inserting a new record into table. When you insert the new record into table, so it will insert this into what? Index. What is insert into index? Name, Blake. Blake is compared with K. Go to left side. Blake is compared with what? G. Go to left side. Adams. No. Ellen. No. Blake. Yes. So already one Blake is there, but you are trying to insert what? Blake is already there, but you are trying to insert what? Duplicate. But what this index is? Unique index. Unique index does not allow duplicates, but you are trying to insert what? Duplicate. Then what this insert command gives? This insert command gives what's that? Error. Okay. So what this insert command gives? This insert command gives what? Error. So what it says, unique constraint is violated. It is giving the index name I3. Okay, that's all. So this command gives error because the index is unique index. Unique index does not allow duplicates, but you are trying to insert duplicate. Index already contains name Blake. Understood then. That's okay. Then that's no. So then, like, what is the question is? How many methods are there? How many methods are there to enforce uniqueness? Hmm? In how many methods we can enforce uniqueness? How many methods are there to enforce uniqueness? Hmm? How many methods you have to enforce uniqueness? Enforcing uniqueness means not allowing duplicates. Enforcing uniqueness means not allowing duplicates. How many methods are there? Overall, like not here, not to this topic. Overall in Oracle, how many methods are there to enforce uniqueness? Huh? So one method is declare what's that? Primary key or unique constraint. This is one method. Another method is create what? Unique index. So there are two methods to enforce uniqueness. You don't want to allow the duplicates. If you don't want to allow the duplicates, you got two options. One option is declaring the primary key or unique constraint. Second method is create what? Unique index. Even if you create unique index also, duplicates are not allowed. Okay, then next. So declare the primary key constraint or unique constraint, create unique index. There are two ways. Okay, not allowing duplicates. Then, and one more thing, we don't need to create index on primary key columns. We don't need to create index on primary key unique columns because primary key columns and unique columns are automatically indexed by Oracle. One index is automatically created on what's it? Primary key column. We don't need to create index. What type of index is created on primary key column? Unique index is created on primary key column. Unique index does not allow duplicate. That is the reason primary key does not allow duplicates. Understood that? Suppose, for example, create table what's it? Customer. Customer ID. Next one, number two. This is what? Primary key. Customer what? Name. This is where cat to 10. So table is what? Created. I'm creating index I10 on customer table, customer ID. What I'm doing? I'm creating index on customer ID, but customer ID is declared with what? Primary key. You see that. What it gets? Such column list is already indexed. That means one index is already created on customer ID. You are trying to create another index. That's why it says such column list is already indexed. Understood, na? Then understood. So who create the index on this primary key? Oracle creates. What type of index is created? Unique index is created. Unique index does not allow duplicate. That is the reason primary key does not allow duplicates. Then, so primary key unique columns are automatically indexed by Oracle, and Oracle creates what, a unique index on primary key unique columns, and unique index does not allow duplicates. So primary key unique also does not allow duplicates. Okay, then next. That's so this is three simple composite and what unique index. All these indexes are what comes under what category? Bitmap. So these three indexes comes under bitmap. Next, one more is there. What is that is? Bitmap indexes. Okay, then so bitmap indexes. Can bitmap indexes then. Okay, and bitmap indexes are created on low cardinality columns. Bitmap indexes are created on low cardinality columns. Okay, na? Then low cardinality columns. What is that low cardinality means? That is columns that contains less distinct values. What is low cardinality columns means? Column that contains less distinct values. Those columns are called low cardinality columns. Okay, then. So columns that contains what? Less distinct values. That column is called low cardinality column. Okay, na? Then meaning, see, meaning is suppose here, for example, okay, then you take for example, see, this is job from EMP, job from EMP. How many values? How many values are there? Job column contains how many values? 14 values. The job column contains 14 values. Yes or no? Then. So suppose if you take, for example, select distinct job from EMP. How many values are there? If you say distinct job, how many values are there? 5. Number of jobs, 14. Distinct jobs, 5. What is distinct jobs means? After eliminating what? Duplicates. After eliminating the duplicates, how many jobs are there? 5. Distinct means unique, unique values. How many jobs are there? How many jobs are unique? 5. Okay. Then similarly, select what? Suppose department number from EMP. Department number from EMP. So how many departments are there? 14. 14. Department numbers are 14. Suppose I'll say select what's a distinct department number from EMP. How many departments are there? 3. Number of departments, what? 14. But distinct departments, how many? 3. 10, 20, 30. After eliminating what? Duplicates. Okay. Then, so what are these columns are called? These columns are called low cardinality columns. What these columns are called? Low card. Number of distinct values are less. Less means less than 200. Number of distinct values are less than 200. They're called low cardinality columns. Understood or not? Then, sir, here, customer table is there. Just listen. Customer ID, customer name, customer address, customer age, customer gender, customer what? City, customer state, like this. This is the table. You take 1 lakh customers. Okay, na? You take what? 1 lakh customers. This table is storing 1 lakh customers data. I select this one. Select CID from customer. How many? Like if you say how many distinct customer IDs are there? 1 lakh. How many distinct customer names are there? 1 lakh. If any duplicates are there, 1 or 2 duplicates. Yes. But here, how many genders are there? 2. MF. So gender is what? Low cardinality. Gender is low cardinality. Is customer ID is low cardinality? No. Because you take 1 lakh customers, how many distinct customer IDs? 1 lakh. Customer name is also not low cardinality because 1 lakh. Address cannot be like, so gender is what? Low cardinality because number of distinct values only 2. State also low. States cannot be 1 lakh. States can be only in India 29. If you go to US 56 or something like that. Yes or no? So states cannot be what? 1 lakh. States are always what? Less. So in this, gender is an example for low. State is also example for low cardinality column. What are the examples for low cardinality column? Gender, but in employee table, job, department number. So all these are examples for low cardinality column. Employees are 1 lakh, but genders cannot be 1 lakh. Employees are 1 lakh. Jobs cannot be 1 lakh. Jobs are only few, 5, 6, 10, 15 like that. Department numbers cannot be 1 lakh. Department numbers are few. So these 3 are examples for what? Low cardinality column. Bitmap index is created on low cardinality column. And why this is called bitmap? Because bitmap index stores bits. Bitmap index stores what's it? Bits. Bitmap index stores bits. Okay, then. stores bits. Bits means ones and zeros, ones and zeros. Okay, then 1 second. Suppose, first see this. Suppose this is the table, employee table. This is what employee, what's it? Department number, job. I'm taking employee department number, job. So department number is 10. Job is what's it? Clerk. Like, okay, not department number. Let's say gender. Let's say gender, job. So gender is M. Job is what? Clerk. Gender is what? F. Job is what? Manager. Gender is what? M. Job is what? Salesman. Gender is what? F. Job is what? Clerk. Gender is M. Job is what? Manager. Gender is what? M. Job is what? Clerk. Suppose. Or salesman. Okay. Then. So this is the table. This is the table. Okay. So the table employee, genders, employee, what? Job. So listen, I created bitmap index on gender. Assume you created bitmap index on gender. BI1. BI1 means bitmap index on gender. If you create bitmap index on gender, earlier if you create the index, what is created? Earlier if you create the index, what is created? You created structure is index, tree structure is created. When you create the index, internally tree structure is created. But here, if you create the bitmap index on what? Then if you create the bitmap index on what? Gender. Suppose create index what? Create index BI1 on EMP. What's it? Gender. Listen. And create index what? BI2 on EMP. What? Job. Suppose one index is created on what? Gender. One index is created on what? Job. What is BI1 contains? BI1 is created with two columns. Structure is different. Bit tree structure is different. Bitmap index is different. Based on the structure, indexes are two types, bit tree and what? Bitmap. Because their structure is different. So bitmap index is created like this. What is? It is created with two columns. Because how many distinct values are there? Two. It's created with two columns. What is the first column? Male. Second column? Female. What is the first employee? First employee. Male. First employee is male. Male. Then this is set to 1. This is set to 0. First employee is male. Male bit is set to 1. Female is set to 0. Second employee is female. This is set to 0, 1. What is the next employee? Male. 1, 0. Next employee is what? Female. 0, 1. Next employee is what? Male. 1, 0. Next employee is male. 1, 0. Like this. So if employee is male, male bit is set to 1, female bit is set to 0. If employee is female, female is set to 1, male is set to 0. Suppose I created bitmap index on job, then I created bitmap index on job, then what? 3. Clerk, manager, next one, salesman. It's created with how many columns? 3 columns. Clerk, manager, salesman. First employee is what? Clerk. Clerk bit is set to 1, 0, 0. This is 0. Next one. Second employee is what? 0, 1, 0. Next employee is what? Salesman. 0, 0, 1. Next 1, 0, 0. 0, 1, 0. Next one 0, 0, 1. That's so bitmap index stores like this. Okay. Then Wow. But in our table, gender is not there, but job is there. So I'm creating the index on job. Index is created. Okay. But we cannot see the index. Select star from index, not allowed. We cannot see the index. Select star from BI2, not allowed. Okay, na? Then index is internal. We cannot, it is not for user. It is for Oracle. Who use the index? Oracle use the index. Why Oracle use the index? To access the data fastly. Created by user, used by Oracle. Views and synonyms we use. We use the views, we use synonyms. But indexes created by developer. We create the indexes, but it is used by Oracle. Oracle will use the index whenever you submit the query to Oracle. Oracle will decide for this query which is best, whether index is best or table is best, or based on that it will choose. Okay, then that's so you submit this query. What is that is select star from what's that EMP where job equals to clerk. Then you submit the select star from EMP job equals to clerk. When you submit this query to Oracle, then Oracle go to when you submit this query to Oracle, Oracle checks any index is available on job. Yes, there is an index available on job. Then it go to that index and it go to what, sir? Because your condition based on what? Clerk. Then it go to this clerk column. In clerk column, it go to one by one, checks bit is one or zero. If bit is one, corresponding record is selected. So it go to the first one. Bit is what? One. If bit is one means employee is what? Bit is one means employee is what? Clerk. Bit is one means employee is clerk. Then select the row from the table. Corresponding record is selected from table. Here, first bit is set to 1. First record is selected. Second bit is 0. Second record is not selected. Third bit is 0. Third record is not selected. Fourth bit is 1. Fourth record is selected. Fifth bit is 0. Not selected. Sixth bit is 0. Sixth record is not selected. So it go to 1 by 1. Checks bit is 1 or 0. If bit is 1, select the corresponding record. Here, first bit is set to 1. First record is selected. Fourth bit is set to 1. Fourth record is selected. Okay. Then. So bit is one, corresponding record is selected from table. Even it doesn't contain row IDs. Bitmap index doesn't store what's her row IDs. Earlier what? Row IDs. So you go to index, find the entry, then take the row ID, go to the table, select the record from the table. But here doesn't store row ID. Here row IDs are not required. Why? Here row IDs are not required. Why? Why row IDs are not required? Here row IDs are not required. Why? Because the first record in index maps to first record in index maps to first record in table. The first record in index maps to first record in table. Second record in index maps to second record. Third record in index maps to third record. Fourth record maps to fourth record. Fifth record maps to fifth record. Sixth record maps to sixth record. That means, see, order is same or not same? Table order, index order is same or not same? Same. That's why row IDs are not required. But here, in this case, order is same or not same? Huh? Index order, table order is same or not same? Not same. So here in index, 1000 is what? First. But in table, 1000 is second record. In here 5000 is last. Here 5000 is last but one. Yes or no? Here 2500 is last but here 2500 is fourth record. Yes or no? So index order, table order is same or not same? Not same. When not same, mapping is required. What that mapping is? Row ID. But here, so order is same or not same? Order is same. When order is same, mapping is not required. That's why it doesn't store row IDs. So once after submit this command, it will go to clerk and check bit is 1 or 0. Bit is 1, corresponding record is selected. Bit is 0, record is not selected. Here bit is 1, corresponding record is selected. Okay, then. So here also, how many rows it has to compare? Here also, how many rows it has to compare? Suppose my table contains 1000 rows. It has to compare how many? Index also contains how many rows? 1000 rows. Okay, na? Table contains 1000 rows. Index also contains how many rows? 1000 rows. How many rows it has to compare? 1000 rows. Then what is the use? Index is for improving the performance, na? Then how performance is improved? Because in table, if it goes to table, how many rows it has to compare? All the means 1000. Let's say 1000. If it goes to table, how many rows it has to compare? 1000 rows. If it goes to index, how many rows it has to compare? 1000 rows. Then what is the use? Then where is the difference between index and table? So if it goes to table, it has to compare all the rows. If it goes to index also, it has to compare all the rows. Then how the performance is improved? So answer is here, if it is table, then it has to check the value. If it goes to table, then it has to compare what's the value. But if it goes to index, comparison is what? Not value, bits. Bit is 1 or 0. If it is index, then what? It has to check the bit is 1 or 0. If it go to table, then it has to check whether the job is clerk or manager or salesman. Okay, but if it go to index, it has to compare bit is 1 or 0. Which is faster? Bit comparison is faster, value comparison is faster. Bit comparison is faster than value comparison. So that's why bitmap index improves what? Performance. Checking bit is 1 or 0 is much faster than checking the job is clerk or manager. Understood that? So bit comparison is faster than value comparison. Okay, that that's so for this query, it goes to bitmap index and go to the clerk column. If the bit is 1, corresponding record is selected. If bit is 0, corresponding record is not selected. Here bit is 1, selected. Here bit is 0, not selected. 0, not selected. 1, selected. 0, no. 0, no. Okay. So when you submit, then it goes to this clerk. It goes to this clerk index and checks bit is 1, select this row. Bit is 1, select this row. That's it. Okay. Then okay. Then. So what are the difference if they ask? Difference between bit tree and bitmap indexes. Bit tree, bitmap. Oh, what are the difference between bit tree and bitmap indexes? Okay, then bit tree created on what? created on what, sir? Created on high cardinality column. This is created on low cardinality. Why? Why it is created on low cardinality? You see this. After seeing this, you can able to answer. Why it is created on low? Sir, here in job column, how many distinct values are there? 3. Then it's created with how many columns? 3 columns. In gender, how many distinct values are there? 2. It's created with how many columns? 2 columns. Okay, na? Suppose if number of distinct values are 500, then it is created with how many columns? 500 columns. So then complexity increases or not? Yes. That's why it is not recommended on high cardinality. It is recommended on low cardinality. Second one, B tree. Next. Next one. So B tree indexes. B tree stores what's that? Stores row IDs, index keys, index key values. Means if you create index on salary, it stores salaries. If you create index on e-name, it stores e-names. But it doesn't store what? Doesn't store index key values. Stores what? Bits. Then so and bit tree stores what? Row IDs. Bitmap what? Doesn't store row IDs. Okay. Then that's so one table is there to get the list. This is the table. User indexes. Stores what? What this stores? Stores indexes created by user. Then how to dropping. So drop index name I1. So if you want to see the indexes list, go to this table. There is a column called index name. Select index name. You know, then that's so index what's it? Drop. Okay. That's so this is about what indexes topic. Okay. Then so what is that? Next. What are the next object? Material reviews. Okay. Okay, now then okay. So we'll do that in the next class, Monday.